Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will talk about chapter 2, Universal Gravitation and Circular Motion. We will revise some points in previous lessons. We will start with Newton's general gravitational law. As we know, if we have two masses like M capital and M small, two different masses, they are separated by distance r, so they will attract each other. And we have a force between them. How can we measure this force? Newton told us that we can measure this force by the following law. F equal Gmm over r squared. F is the force between two masses. Two masses attract each other, yes. But this law is applied only for the large masses. G is called universal gravitational constant. And mm is the masses of the two objects. R squared is the square distance between them. So we must know some points in this law. Number one, G. G is called universal gravitational constant. What's the value of G? G equals 6.67 times 10 power negative 11. Measuring unit of G is Newton meter square per kilogram square. Or we have also some equivalent units like joule meter per kilogram square or meter cubic kilogram bar negative 1 second bar negative 2. These are the measuring units of G. We must know some notes. This mutual force between two masses are equal or the same for the two masses. This means that the large mass attracts the small mass by the same force which small mass attracts the large mass. Two forces are equal. Example for this, we have two small balls of masses 7.3 kilogram. Each are separated by distance 0.5 meter between their centers. We measure the distance from the center of the two objects. We want to measure the mutual attraction force between them. So, F equals Gmm over r squared. The value of G 6.67 times 10 power negative 11. First mass equals 7.3. Second mass equals 7.3. So, mm equals 7.3 squared. And the distance between them 0.5 meter. So, the value of this force equal 1.4 times 10 power negative 8 Newton. As we know, this value of this force is very small value. So the value of attraction force between small masses, 7.3 kilogram, small mass, is very small force, 1.4 times 10 power negative 8, very small value. Next, we will talk about gravitational field. Gravitational field, as you know, each mass has a gravitational field. Each mass can attract the other mass by a force, so it has a gravitational field. This gravitational field means any object inside this field can be attracted towards this mass. The gravitational field intensity is measured by gravitational acceleration g. Gravitational acceleration g, as we know from Newton's second law, g or a equal f over m. Here we have acceleration equal g. So g equal f over m. From Newton law or universal law, as we know, g equal gm over r squared. Here, r squared is the distance between the object and the other object. So we can measure gravitational acceleration of any planet as the following: g equal gm over r squared. If we want to compare between acceleration of gravity of two planets, g1 over g2 equal m1 over m2 r2 square over r1 square. And when the other object is at a height equal h, so the distance equal r plus h all power 2. Or at depth, so distance equal r minus h all power 2. These points for revision. So, if we wanted to talk about satellites, Earth can attract or Earth attract any satellite revolve around it by a force. This force is a gravitational force and also centripetal force. So satellite revolve around the Earth like this. So it has a centripetal force mv square over r, and attracted towards the Earth by a force equal gravitational force Fg, which is equal gmm over r square. We can equalize these two forces from the following relation: F equal mv square over r, centripetal force, and equal gmm over r square, gravitational force. From this relation we can conclude that V equal root gm over r. G is the gravitational constant, m is the mass of the planet, like Earth, r is the distance from the center of the Earth to the satellite. And r can be calculated as the following: r equal r plus h. R capital means radius of the Earth, and h is the height of satellite from the surface of the Earth. So this is the Earth, and we have a satellite revolve around the Earth. We measure the distance from the center of the Earth. This distance is called r, and this distance is called h, and this distance is called r, radius of the Earth. So from the following relation, V equal root g m over r, and r here equal r plus h. So orbital velocity of satellite, or the velocity of satellite which revolve around the Earth, depends on g is a constant, and mass of the Earth, and distance between the center of the Earth to the satellite, or the height of the satellite from the surface of the Earth. As the mass of the Earth or the mass of the planet increases, orbital velocity increases. And as the distance between the center of the Earth to satellite decreases, orbital velocity increases. And now we have the following example. The moon rotates around the Earth in a circular orbit of radius 3.85 times 10 power 5 kilometer, and completes one revolution in 27.3 days. Calculate the mass of the Earth, knowing that universal gravitational constant equal 6.67 times 10 power negative 11, and pi equal 3.14. So if you want to measure the mass m, from the following relation, v square equal gm over r, or as the following relation, v equal root gm over r, we square both sides to be v square equal gm over r. So m equal v square r over g. So we must know orbital velocity of satellite and r distance, and g as it is a constant value. To measure orbital velocity of satellite, as the following relation, v equal 2 by r over t. T is a periodic time. So 2 times 3.13 times 3.85 times 10 power 5 times 10 power 3 to convert it into meters over t periodic time, 2.36 times 10 power 6. It will be equal 1024.49 meter per second. Then mass v equal v square r over g, which is equal 1024.49 square times 3.85 times 10 power 5 times 10 power 3 over 6.67 times 10 power negative 11, which is equal to 6.06 times 10 power 24 kilogram. Another example, satellite rotates around the Earth in a regularly circular orbit at height of 940 km above the Earth's surface. Calculate the orbital velocity and the time required by the satellite to make a complete revolution around the Earth. Knowing that R equal 6363 km, M equal 6 times 10 power 24 kg, and G equals 6.67 times 10 power negative 11, and pi equals 3.14. We have the following givens here: each height and radius r, mass of the planet, and G, which is a constant. To measure velocity v equal root gm over r. We have all the givens, but only we must know r distance from the center of the Earth to the satellite. R equal r plus h. So r here 6360 kilometer plus h 940 kilometer, which is equal to 7300 kilometer or 7.3 times 10 power 5 meter. So v equal root gm over r, which is equal to 6.67 times 10 power negative 11 g times 6 times 10 power 24 m over 7.3 times 10 power 6 r, which is equal to 7.4 times 10 power 5 meter per second. To measure periodic time here, we must use the relation t equal 2 by r, v equal 2 by r over t. And finally, study hard and thanks for listening.